Questions involving area and volume scale factors can cause problems, but if you remember how they both relate to the linear scale factor, then you should be able to find your way through to a solution in these questions. The things to remember are that the volume scale factor is the linear scale factor cubed, and the area scale factor is the linear scale factor squared. There is a relationship directly between the volume and the area scale factors, but I think it's so much easier to always refer back to the linear scale factor and then move from that point. So looking at this question here, we have two similar metal statues. They are not drawn accurately, so please don't take measurements from them. They will be giving you the wrong answer if you do that. The information here says that the volume of statue B is 20% less than statue A. So just writing that onto the diagram here, I'm subtracting 20% of the volume to go from A to B. If I'm doing that, I'm going to multiply by 0.8. That should be a familiar conversion for you. You're taking away 20%, that leaves you with 80%. 80% is a decimal, is 0.8. So I've been multiplying by 0.8 to go from left to right. That will be my volume scale factor, my VSF. So the first thing I'm going to do is say, well, my linear scale factor is equal to my volume scale factor, which is 0.8, and it's cube rooted. Now, looking at the question, it asked for answers into three significant figures, so I'm going to work to around about 5, which I would recommend. You certainly need to go to at least one more than what the question says to make sure your answer is accurate enough in the final time. So we've got 0.92832, that's what I get when I cube root 0.8, and that is my linear scale factor. Now from there I can work out my area scale factor. My area scale factor is my linear scale factor squared. So I take the 0.92832 and I square that, and my area scale factor now works out to be 0.86177, and it carries on. And that is the area scale factor. Okay, looking back at the question, it says that the surface area is K% less than the surface area of statue A. Okay, so what I'm doing here, I'll write this in blue, is I am subtracting K%. That's what I want to find out. What percentage am I taking away? It's a little bit of a tricky question, I suppose, looking at that. Now, I know my area scale factor is 0.86. That would be my multiplier. So going from A to B, I would multiply by 0.86177. Now, that would mean I actually end up with 86% or 86.17% of of shape A. So I'm multiplying by 86.177%. That's how I'm going to phrase it. Okay, all I've done is I've taken my decimal and I've turned it into a percentage. So if I'm multiplying by that, what percentage have I lost? Well, clearly I started with 100%. So I had 100% and I took away 86.177%. And that leaves me with 13.8%. So I am subtracting 13.8%. So that is my value of K. And that's my question finished. It's quite a strange one, the second part. The first part is fairly conventional. So just to recap, when you have a volume scale factor or a volume reduction, you can work out, or an enlargement, as long as you can work out the volume scale factor, you can always work out the linear scale factor, cube root. Once you have a linear scale factor, you can work out an area scale factor by squaring. Then with this question, you have to analyze that answer there and say, well, what does it mean? It means I have a certain percentage of my starting value. So I've lost, in this case, a certain percentage. So I take that percentage away from 100, gives me my 13.8. And it asks for the answer to three significant figures, so you should get 13.8 to the correct accuracy.